Hi there, this is Gu Shuli from UC Santa Barbara. At ASPLOS 2019, I will present our work tackling the Qubit mapping problem for NISQ-Era quantum devices. The Qubit mapping problem comes from the limited 2-qubit gates on NISQ devices. 2-qubit gate is important in a quantum program and can be applied to arbitrary 2 logical qubits. However, not all 2-qubit gates are directly executable on hardware. On the promising superconducting quantum processors, 2-qubit gates are only allowed on nearby physical qubits, which are connected by resonators. The initial mapping from logical to physical qubits must be carefully designed, and additional operations need to be introduced for dynamic rewrapping during the execution. To finally make the quantum circuits executable and reduce the overhead, the quantum compiler must convert the hardware-independent program to hardware-compatible program, with additional operations as few as possible. Previous solutions to this problem are not flexible, scalable, or effective. Our approach eliminates these drawbacks with 3 key designs. First, we only search for possible swaps associated with high-priority qubits, leading to an exponential speedup. Second, we update the initial mapping through a reverse circuit to further reduce the overhead. Third, our approach could trade off circuit depth with gate count by selecting non-overlapping swaps. The results show that our approach could find near-optimal initial mapping for small circuits and generate comparable results with much less runtime for larger circuits. We also achieved 8% circuit depth variation. If you're interested, please join our presentation, the second talk in quantum computing session at 2 p.m. on April the 17th. Thanks.